Hello, everyone. We did the intermediate value theorem part 1, and this time I'm going to do intermediate value theorem part 2. And just to recap on what we did last time, that a function is a rule that assigns an input exactly one output. That's a definitional function. When we look at the theorem of which is called intermediate value theorem, we understand that all these quantities, they belong to a different category. X, A, B, C, these are inputs. F of X, F of A, F of B, F of C, those are output, and capital N is in the same category of output. And we know that there are two versions of intermediate value theorem. The intermediate value theorem, one is the theorem itself, and the other one is its corollary. The corollary, which is, it's more used than the theorem itself. And of course, the theorem includes the case for the corollary case. Okay, so here I'm going to quote both cases. Okay, I'm going to bring it up to our study. Okay, and so in this time in the lesson, we're going to talk about some situation that the theorem, the interval was not given. The interval was not given. For example, if you look at this, let me see if you can see that. Okay. Yeah, you can see that. In this case, say number 57, right? This is, I think I have given you this as homework, is that prove that the equation has at least one real root. We're not going to do the second part, right? Use your calculator to find the interval of length of 0.01. We're not going to do that part. We just want to apply the intermediate value theorem. I'll take the first one, right? And obviously, we're going to be using the corollary. So I'm going to put the corollary on top. The corollary, there's a conclusion there, right? The conclusion is right there. There we go. The corollary, and we're going to look at this example, this question of cosine x equals to x raised to the power 3. Once again, this is to find, we just want to know, we're going to do A, okay? We're not going to be doing to find the actual solution. We're not going to be finding the actual solution. How do we demonstrate there is a solution? Okay, it said there's at least one. Well, if we can find there is one, then we have demonstrated there is, there's at least one. Okay, so we just have to apply the theorem to demonstrate that. So now we're going to create the function. We're going to create a function, and this function is going to be created by making the given equal to 0. Okay, you can create it any way you want. You can create a cosine x minus x to the power 3 or x minus 3 minus cosine x. So it doesn't matter. So if I do x raised to the power 3 minus cosine x, that's fine too, anyway. And this function obviously is continuous on the entire number line, right? The domain all real numbers, domain all real numbers, and this is a continuous on the entire domain of the two functions. They have the same domain, and we just have to identify, we need to identify the closed interval for which we can apply the you know, the theorem. Now, knowing that cosine x is bounded, is between -1 and +1. So when we create that, when we're looking for those values, so to find those A and B, you want to have a piece of scratch paper. Okay, so I'm going to scratch paper. Or I also call it think out loud. Okay, think out loud. So you would have experimented, okay, try the different numbers to identify that A and B, that closed interval. So we need to find that closed intervals so that the two conditions are satisfied. Okay, so you have a secret paper that you don't want to turn in, and you work on it and you identify the two numbers. Is that solution has to be unique? Most likely it's not going to be unique. So, you know, one person's solution may be different from another one's solution. Okay, so now let's try some random numbers. Say I'm going to try f of 0. That's the easiest thing you can try, right? F of 0, that equals to replace x by 0 and cosine 0. 0 to the power 3 is 0 minus cosine 0. Cosine 0 equals to 1. Yes, equals to 1. Therefore, this f of 0 equals to a negative number already. So next, you want to find a positive number, right? You want to find a positive number. And what would that be? Then you probably think about cosine values. You can use a calculator if you want to, right? Cosine 0 itself is 1, so there's a negative sign in front of it, just to make sure you got it, okay? So what I'm going to do, the next point, I'm going to try, make it easy number, right? How about pi over 2? Pi over 2. Well, you can try pi if you want, right? So pi over 2 is identified. Let's see what happens. And this is pi over 2. Cosine pi over 2 is 0. Pi over 2 to the power 3 for sure is going to be positive. Okay, there we go. We have identified the interval. So now what do we say? Now what do we say? We can say, hey, we can make some adjustment, right? So what I did, okay, suppose all of these are scratch paper, on scratch paper, arena, you know? And when I show the work, right, it is continuous on a closed interval, and I already found that interval, and that interval is 0 pi over 2. Okay, you can do whatever on your scratch paper, but when you present your work, you want it to be nice and clean. Okay, so f of 0 equals to a negative number. F of pi over 2 is a positive number, so we found the interval, and that interval is 0 comma pi. And by this time, f of 0 multiply f of pi over 2 is negative. So the theorem, the condition, the premises in the theorem are both satisfied. They're both satisfied. And then what? Well, we can apply the conclusion, right? The conclusion. Then you say there exists. Okay, so these are the words you like to use. By intermediate value theorem, there exists a number C between 0 and pi over 2, right? Such that f of C is 0. That's the words you want to use. Okay, that is What do we get? F of C is when X is replaced by C. There. We have demonstrated there's one, and then we have demonstrated there's at least one. So that's what it is, equal to 0, right? Or you can say C cosine C equals to C to the power 3. So there is such a solution, and C does exist, right? So there's a solution. So this piece is really all the work you need to show. This piece. Okay, a lot of the work to find the interval, you're going to put it on scratch paper. Just put it on scratch paper. Okay. Maybe I'll do 58. Maybe I'll do 58. All right. Example number 2. Number 2, right? We have ln x. Take this opportunity to review ln x. 3 minus 2x. We don't know the interval. Right, we don't know the interval, and we know that we need to find that interval. And here we go, right? We need to create a function. So the function we're going to create is going to be ln x, if you want, minus 3 plus 2x. Or you can write plus 2x minus 3. Same thing. Okay? You just make sure you operate it properly. You should be able to go back. Okay, if this is true, minus 3 plus 2x, we got it. Okay, so on the scratch paper, let's see scratch paper, or think out aloud. Think out aloud, right? I need to figure out that 2 number. It's a process of trial and error. ln 1 is 0, so we may think of, hey, let's try ln 1. X replaced by 1. ln 1 is 0, right? So it's 0 minus 2. 0 plus 2 minus 3. It's a negative, right? If I go to work, and then what? Let me think of, how about f of e? Huh? ln e is easy. 2 times e. ln e is 1 plus 2e minus 3. Is that going to be positive or negative? 2 times e. E is 2.7. Right? 2 times 2.7, definitively, that's going to be larger than 3. And then we're adding 1. So this is going to be positive. We have identified the interval. What interval is that? That interval is 1e closed interval. So now we can say in the solution, I'm going to say f of x is continuous on the closed interval 1, e. Okay? And the first condition is checked, it's satisfied. Number 2, I'm going to move these 2 up. Okay? F of 1 times f of e is less than 0. So f of 1 multiply f of e is negative. Second condition is satisfied. And then what? Well, we just apply the corollary. You can see the work we show here. It's just I intermediate value theorem. there exists number C in 1, comma E, don't forget to change that, such that f of C equals 0. I.e., right, what is f of C? F of C is this piece replaced X by C, that equals to 0. Okay, and if you transform that, we get easily this form, right? And that's ln C equals to 3 minus 2C, right? Which matches the given equation. And we know that there's a solution between 1 and E inside that interval. And we're done. We're done. Okay, we're not doing the B part as of now. We just learn how to use this language of intermediate value theorem and to apply intermediate value theorem on how to illustrate it. Okay, how to illustrate what to do, what to say, right? Just quote the theorem. The more you quote, the more points you're getting. Okay. I think that's all for this lesson. Thank you for watching. Until next time.